In biosensor part 2s are classification of biosensors, what are nanobiosensors, applications of biosensors, and the characteristics of ideal biosensor. Now moving toward the classification of biosensor, the classification is based on two type of component. First is the bio component and second is the transducer. According to the biocomponent, it is classified as antibody biosensor, enzyme biosensor, cell, DNA, phage biosensor. And according to the transducer, it is classified or divided into optical biosensors, piezoelectric biosensors, and electrochemical biosensor. Further, electrochemical is further divided into three type of biosensors. Those are amperometric biosensors, potentiometric biosensors, and conductometric biosensors. These are different type of biosensors. Now we will discuss about the biosensors according to the transducers. Based on the transducer, the first type of biosensor is the optical biosensor. It is based on calorimetry, in which it measures the light absorbed by a reactant to form a product, and also it is based on photometry, in which photons liberated are detected by photomultiplier or photodiode. Next is calorimetric biosensors. Calorimetric biosensor is used to measure the change in heat of the analyte when the analyte as a reactant change into a product. The next type of biosensor is potentiometric biosensor. In this type of biosensor, it detects the change in the distribution of charges. The next is piezoelectric biosensors. This is another type of biosensors which detect the angle of electron waves emitted from analyte when exposed to laser light, or from analytes when exposed to the laser light, or from vibrating crystals, example quartz, in an electric field. Next type of biosensor is an electrochemical biosensor. It is of three types: amperometric, conductometric, or potentiometric. These all three works on the principle of detecting change in the electrical properties. Next, this is the slide for nanobiosensor. It is an advanced type of biosensor. It is called as nanobiosensor because all the components in these biosensors are of nanoscale, and the nanoscale biosensors, the components are called as nanosensors. Now moving toward what is nanosensor. The nanosensor used as a first, second and third component. They function similarly to that of the biosensors, but the basic difference is that they can detect a nano-sized analyte and the reaction in which that means the analytes involved. Next, the application of biosensor. These are some of the applications of biosensors. We can see that it is related to every biological field, every biological science field. It is related to food analysis. It is related to the study of biomolecules and their interaction, drug development. It is also applicable in crime detection, medical diagnosis. It is both applicable in clinical and laboratory use. It is used to detect the environmental field. It is used for monitoring environmental pollution. It is used in quality control in industries. It is used to detect the biological warfare agents and in manufacturing of pharmaceutical or replacement organs. Next, application of nanobiosensor. Nose is a nanobiosensor, have several applications in food and pharmaceutical industries. It is also applicable in medical and health sector. Next, this is a slide which shows that there are some of the characteristics of an ideal biosensor, such as for an ideal biosensor, the output signal should be relevant. Its functional surface, that is the bioreceptor, should be compatible with the transducer. Next, it should have high specificity and should be highly sensitive toward less concentration of specific analyte. Further, they should also have some other characteristics, such as it gives accuracy and exact value if the function of the biosensor is repeated. It should be fast in response. It should have dynamic range and also should not be sensitive to other environmental factors. This is all about biosensors. It is the end of the topic 9. Thank you.